So let's incorporate some transformations of functions and graph trigonometric functions with a vertical shift. If you take a look at the -3, the -3 is an addition or a subtraction outside of the function. So this is going to lift the graph up and down. So since it's negative, the graph is going to move down 3 units. So let's just identify all of the parts of a trig graph. The 4 is the amplitude, as we found out last lesson. The 2 is the frequency, as we found out last lesson. And today, this is the shift, but it's a vertical shift because it's outside of the function. If we just recall back to something, work down here for a second. Back from second quarter, if we have y equals x squared, and we work with y equals x squared plus 4, well, that lifts the graph up 4 units. That's a translation in the y direction. It's exactly what we're doing here. So we're not really learning anything new, we're just applying it to a new function. So, in this case, the shift is -3. So the graph is going to move down -3. So let's think about what the graph would have looked like without that -3. 4 sine 2x would have looked like this. You have your 5 ordered pairs. 1, 2, 3, 4, 5. And now these 3 ordered pairs would have lied on the x-axis, but now they're moving down 3 units. So I'm going to go to the next page, and I'm going to see what y values all of these reach. So we were working with the function y equals 4 sine 2x minus 3. We're going to graph this function from 0 to 2 pi, but before we do that, I'm going to sketch a sine cycle. I'm going to plot the 5 ordered pairs, number 1, number 2, number 3, number 4, and number 5. Just recall there are only 3 spots on the y-axis where you can plot ordered pairs. The 3 spots are the max, the min, and the middle. So now let's try to figure out what these 3 values would be from this equation. So now the middle will always be your shift. So that means that the middle of our graph is -3, has a y value. The amplitude is telling you how high to go up and down from that number. So from -3, we're going to go up 4 and down 4. That's what the amplitude is. The amplitude is this number. That's the amplitude from the middle of the graph to the maximum value, or from the middle of the graph to the minimum value, the distance. So let's try to figure out what values we'll have here. So if we're starting with -3 and the amplitude is telling us to go up 4 and down 4, that means we're going to have to reach +1 as a maximum value and -7 as a minimum value. So those are the spots we're going to put on our y-axis. So let's set up an axis. Y equals 4 sine 2x minus 3. Let's set up a y-axis. Let's put -3 right in the middle. We're going to go up 4 to +1, and we're going to go down 4 for -7. Okay, so now put your x-axis where it makes sense. The x-axis is y equals 0, so that's going to be right here. There's our x-axis. We're still going to set up our x-axis exactly the same. The only thing different here is where we're going to plot our 3 ordered pairs. So every 4 boxes is 90 degrees. 1, 2, 3, 4. Pi over 2. 1, 2, 3, 4. Pi. 3 pi over 2. And 2 pi. There's our x-axis. And just recall, you could only plot graphs at the maximum, the middle, and the minimum. So we're not going to plot any order pairs in the x-axis. The x-axis is simply here to help you determine where the graph lies. We're not going to plot anything on the x-axis, but I am going to include a dotted line on -3 to remind myself to plot ordered pairs there. So let's put a dotted line there. And now we're going to be plotting ordered pairs at 1, -3, and 7. Let's sketch ourselves a sine cycle so we can see where to start and end. Start on the line, end on the line, across the middle on the line, maximum, minimum. There are our 5 ordered pairs for our sine cycle. So sine starts on the line. In this case, the line is at -3, so we're going to start it at -3. Now we have to determine where to end our first cycle. Well, the frequencies too. So by the time I'm done graphing, I will have seen 2 sine cycles. So let's find a period which will tell us where to end the first one. The period is 2 pi over the frequency, and the frequency is 2. 2 pi over 2, pi. That's where we're going to end our first cycle. So now we started our cycle on the line, end our cycle on the line. Where? Wherever the period tells you. So at pi, we're going to end our cycle exactly where we started it. Okay, so we've already plotted this ordered pair and this ordered pair. Now halfway between these 2 ordered pairs across the axis again. Well, this is separated by 8 boxes, so half of that, 4 boxes. Okay, so we've plotted the 3rd order pair. Now we have to plot the maximum. The maximum is 1. That's separated by 4 boxes. So 2 boxes over is going to reach 1. So now we've plotted that order pair. Now let's plot the minimum value. It reaches the minimum halfway between the 2 points where it crosses the axis. So halfway between these 2 ordered pairs, between pi over 2 and pi, that's 4 boxes. So 2 boxes over, it reaches -7. There's 1 complete cycle. So now, these 5 ordered pairs, the last ordered pair becomes the first ordered pair for your next. So let's sketch another sine cycle. 1, 2, 3, 4, 5. We've already plotted ordered pair number 1, because ordered pair 5 becomes ordered pair number 1 for the next cycle. Let's end our cycle, every distance of pi. We started it on the dotted line, ended on the dotted line. You're going to end your cycle exactly where you started it, on the same horizontal line. So that means we plotted the last ordered pair. Halfway between these 2 across the line again. Halfway between these 2, well, that's separated by 8 boxes, so 4 boxes over, 3 pi over 2. And now halfway between these 2 ordered pairs, it reaches its maximum. This is separated by 4 boxes, half of that's 2 boxes, reaches its maximum. Notice, I'm not plotting on the x-axis. I'm only plotting at the max, the middle, and the minimum. And we've plotted that one. Last one is the minimum value, which is halfway between these 2 ordered pairs. That's these 2 here, halfway. That's 2 boxes, down to the minimum. And let's just plot, making it look like a sine cycle then. And there we go. There's y equals 4 sine 2x minus 3.